Next topic is capacitance of conductor. Means when we charge of any conductor, they have a charge Q, and Q is proportional to the increase the potential. So here charge Q is proportional to the increase. When we increase the potential, increase the charge. So Q is proportional to the increase the. So Q equal to C into V. C is a proportional constant and C equal to Q upon V. What is the C? C is a constant that is called the capacitance of the conductor. C is the capacitance of the conductor. So we can explain by the, if we take 1 volt, this charge, unit volt charge is called by the capacitance of conductor. So we can say the ratio of charge and volume is called by the capacitance of conductor, and we can say unit potential charge is called by the capacitance. And here capacitance is also a new physical quantity. So what is the unit and what is the dimension and what is the quantity? Scalar quantity, unit. If we take the SI unit, that is the coulomb upon volt. Dimension, we can calculate the dimension. What is the dimension of coulomb A1 T1? What is the dimension of volt? Means M1 L2 T minus 2 upon A1 T1. Because what is the potential? W upon Q naught. So this dimension is here and this dimension is here. So the net dimension will be M1, M minus 1, L minus 2 and T plus 4 and A2. So this is the net dimension. And what is the quantity? Quantity is scalar because this is a constant quantity. So we can write the graph between Q and V, then Q is proportional to the V. Q is proportional to the V. And this is the SI unit. At first I discuss about the SI unit, that is the coulomb per volt. We mostly use the unit is coulomb per volt, that is called the farad. 1 farad equal to 1 coulomb volt. That is the SI unit, coulomb per volt, and generally we use the capacitance as a farad. We can say millifarad means 10 raised to the power minus 3 farad. Microfarad means 10 raised to the power minus 6 farad. Picofarad, nanofarad 10 raised to the power minus 9 farad. And picofarad means 10 raised to the power minus 12 farad. So this is mostly we can use the numerical as in terms of farad, the unit of capacitance. Next, that is the Cgs unit, and we just about the farad and Faraday. What is the unit of Faraday? Here is farad. Farad is the unit of capacitance and Faraday is the unit of, what is the unit of charge? So farad and Faraday is different because farad is the unit of capacitance and Faraday we have already studied about the electrostatics first chapter, that is the unit of charge. So farad and Faraday is different. So farad is the unit of the capacitance. And next is Cgs unit. We can also calculate the Cgs unit. What is the Cgs in coulomb? 1 coulomb equal to 3 into 10 raised to the power 9 state coulomb. And what is the volt? 1 by 300 state coulomb. So the net 1 farad equal to 9 into 10 raised to the power 11 state farad. This is the relation between SI unit and CGS unit. 1 farad equal to 9 into 10 raised to the power 11 state farad, because this have already in electrostatics and this have already in electrostatics units. So the basic difference is farad and farad is different unit. So here the unit of capacitance is farad. Next, what is the relation between Q and V? So we can graphically the relation between Q and V. Q is proportional to the V. So here tan theta. What is the tan theta? Tan theta equal to Q upon V. This tangent is called by the capacitance also in graphical representation. For example, we take two different metals, different material which have different tangent. Means this is A material, this is B material, this is Q, this is V, and this is theta 1, this is theta 2. And I have to calculate which metal have the most, which metal have more capacitance compared to A and B. So we calculate what is the tan theta. Tan theta is B is less and tan theta is A is more. So the capacitance of A material will be greater to the capacitance of B material. And some of examples in exams, this will be inverse also. To the Q and V, here V and here Q. What is the tan theta? Tan theta is 1 by C, means V by Q. So here, when you increase the tan theta, decrease the capacitance. When you increase the tan theta, increase the capacitance. So in numerical questions, at first you see what is the graph between Q and V and V and Q and Q and V. So you calculate the tan theta relation between Q by V and see in the graph and solve the question easily. So this type of question also at the Ohm's law, this graph represents various type of numericals. So this is the basic concept of capacitance of conductor, that is the C equal to Q upon V, unit, dimensions and graph representation. The next topic is of an isolated spherical conductor. We have to calculate the capacitance of isolated spherical conductor. For example, we take a spherical conductor which have the capital Q is equally distributed on this R, capital R radius spherical conductor sphere. So this sphere we have to calculate the capacitance. What is the electric potential due to the spherical charge conductor? We have already in chapter 3 the electric potential due to this spherical charge 1 upon 4 pi epsilon naught Q upon R. This is the electric potential due to the spherical conductor which have the Q is equally distributed on this spherical conductor and V is the potential. And what is the electric field? Electric field is 1 upon 4 pi epsilon naught Q upon R square. This I have already studied in previous chapter. So here we have to calculate the capacitance. What is the definition of capacitance? Charge upon volume. Put the value of electric potential in equation first to equation second. So C equal to Q upon 1 upon 4 by epsilon naught Q upon R. Here Q to Q cancel out. So C equal to 1 upon 4 pi epsilon naught R. That is the capacitance of an isolated spherical conductor. In which condition? In vacuum condition, because I have take the vacuum condition in this epsilon naught. So here the capacitance of isolated sphere we have already discussed about the electric potential 1 upon 4 pi epsilon naught Q upon R, that is the electric potential. By the definition of capacitance, that is the Q by C. Put the value of electric potential in this equation and calculate the C equal to 4 pi epsilon naught. Means C is proportional to R. C is proportional to R means when you increase the radius, increase the capacitance. This is the first objective unsolved problems of RBSc book. When you increase the radius, increase the capacitance of spherical conductor. This formula for vacuum condition, when we use dielectric or some medium, then what is the effect? When we fill up this material or fill up this conductor with dielectric constant, that is the epsilon R. And what is the electric field, electric potential in this dielectric medium, that is the epsilon naught R. So when you put by the definition of capacitance C equal to Q upon V, put the electric potential from this equation, and what is the relation? That will be the C equal to epsilon naught epsilon R. That is the capacitance in medium. So we can, when we use the dielectric medium, the capacitance is increased. Capacitance is increased when you use the dielectric medium. So when we use increase the radius, increase the capacitance. When we use the dielectric constant, dielectric medium, increase the capacitance. So this is the capacitance of an isolated spherical